This is the third and final video focusing on the Node backend of the three-tier architecture. This one focuses in and gives all the details and specifics of the code to run the Newswatcher application. The first video and the second video that you should watch show you the foundations for understanding how Node works as a framework, and then some sample code to get you up to speed. This is the hosting diagram for Newswatcher. It starts with the React application at the top, but really the Node application code is running in Elastic Beanstalk and the Lambda. Involved with this is an AWS Route 53 DNS that gives you the domain name service so that we can host Newswatcher to our web. There is a certificate for that that's hosted inside Elastic Beanstalk. We'll get a breakdown of that in just a second. The Lambda then runs code that just needs to be run periodically that are these short little snippets of code. There's one Lambda, and it can also be not only be invoked from Elastic Beanstalk, but it can be invoked on a timer, and there's different usage of that. Here then is the in-depth diagram of hosting with Elastic Beanstalk in a secure way that's scalable. Inside Elastic Beanstalk container is everything that is really going on. And when you start up Elastic Beanstalk, when you instantiate one and create one, it gives you some of this by default, but other things you have to set up by hand. So for example, it will set up some EC2s in subnets, but you need to change those to be private subnets unless you have one, and that's where it put them. And you also need to alter how many instances are in the scaling group. You can actually set up Elastic Beanstalk with only one EC2 without a scaling group, or as one of the setup options, you can set it up to scale and tell it how many EC2 instances you want minimum and how many you want maximum, and what are the data points that it's collecting to decide when to scale up or scale back down. Let's next look at the VPC. So VPC in AWS stands for Virtual Private Cloud, and that's basically your networking ability. So it gives you the ability to set up routing and IP addresses internally, as well as expose IP addresses externally. A good practice is to create public subnets and private subnets. Sometimes you might want to host an EC2 in a public subnet, but most likely your database and your app servers, they want to be hosted behind that public subnet and actually in a private subnet. So one of the things you do then is you create this NAT gateway that allows access out from the private subnet. Incoming requests then to be balanced across the instances in Elastic Beanstalk, they would come in. So example from the SPA, from the single page application React JavaScript application, a request for a get or a put or a post would come in through Route 53. The browser then would know, okay, where does this have to route to because of Route 53 and the domain to the actual IP address. That then routes to the application load balancer, and then those instances are then routed to, and they can call back out. Now, an instance could call back out on its own, and that's how it would actually reach without a get coming in or a put or a post. If there was some kind of timer, it could actually reach out through the public subnet and make a call to the internet. Scaling-wise, let's talk about that. The endpoint here, Route 53, and the load balancer obviously could support thousands of requests every second. And we call this a stateless architecture, meaning that each time a request comes in, let's say you log into Newswatcher and now you have an application session, there's no need to really route you to that same EC2 instance that you initially contacted and gave your username and password and got a token back. Every request that comes in could go to a different EC2 instance. The Lambdas, of course, scaling is pretty much infinite. you get 1,000 invokes at a time when you set it up. You can actually up that amount. We won't reach anywhere near 1,000 probably with the number of users that are using Newswatcher. The other piece that's hosted in AWS is Atlas MongoDB. There is a DocumentDB version of that. That's Mongo. That's hosted by Amazon AWS. That is available as well. Then outside of AWS is the New York Times newsfeed. Now we can methodically walk through the code. So the rest of this video will pretty much focus on code. As we did with the React video, the third video, we showed you code. Now there we were able to show you, the UI, and then we could show you some React code. Here, we're just going to be looking at code. The first file to look at would be the package.json. Now this is a monorepo. So what that means is all the code is in one repo in GitHub. You could split it up, especially if it was microservices based. You could create a repo for each, that's a repository, right? Code repository for each service. Here all our services are in the same code base for React. However, just because it's a monorepo doesn't mean it's all deployed together. So the Lambda, for example, is separate code that's deployed, and the React application is actually built separately, even though it's serviced from the Node server. But it could be placed also separately in a deployment, such as putting it up on S3 or CloudFront. So these dependencies, what I'm getting at is these dependencies right here are for both the Node server as well as the React code. So first off, let's focus in on the server then. There's also an SSR render. I'm not going to get into that. That's for server-side rendering if you want to understand that. And it's not in play at this point. Here's a require for .env. I covered this in a previous video, that this allows you to get environment variables out of a .env file. I'm not going to do that because then you would know my passwords and things like that. So we'll see later that we get a connection string for what we need to connect to MongoDB with. Now the great thing about this is it allows me to run this locally on my machine, as well as then in AWS, where I set up the Elastic Beanstalk and Lambda. I actually create environment variables there. So the same environment variables that are set up in my .env file, so I don't have to set them up on my machine. I can just have them in this file and change them easily. But those same environment variables are then added to Elastic Beanstalk's environment, and then every machine that it spins up for EC2 gets those. So the connection string, in other words, is here in my .env, but it's also set up in the Elastic Beanstalk environment. Here's, like I said, we're not going to cover server-side rendering. I can set a flag in my environment to say whether or not we want to do that. So we already covered Express. Path is something that helps you get at locations that are relative to your application that's running. Logger puts log statements out to the command prompt when you run it locally, and you could also see those in CloudWatch. Response time, then that gives you response times for automatically for any HTTP requests that come in. Helmet we'll cover in a second. That is for mitigating security risks. Rate limiter, same thing. This is basically limiting by IP, so you don't have DDoS attacked by IP addresses. And compression, so we can compress the data going back and forth. And then these are the routes. So these are the other files that are under the directory up here called routes. And you can see we don't have too many routes, right? We have a route for users. Logging in is through the sessions, and then we have shared news and home news. So these are basically modules that we created that we can import as we do here with the require statement. Just as we saw with our other video, in video number 2, we saw the use of Express. This one is necessary so that we can be behind a proxy. This is turning compression on. Again, it's easy to put in with one single app.use statement. Now we talked about the rate limiter that we required here, express.rate-rate-limit. That's an NPM package that we're importing. It's a rolling window, and there's a max of 2,000 per IP address. Now we can actually skip certain rate limiting testing, because when I run my tests that I want to run for load testing, for example, I want that turned off. Now here's the use of helmet. This sets up our security policy. And so helmet, basically we take the defaults. This mitigates a lot of risks, such as cross-site scripting and forgery attacks. Pretty easy to set up and get running there. As we said, the response time, the logger, these are middleware for Express, and then JSON, meaning we want a property. Whenever we get JSON, we want a property called body that's on the response. Now, we won't go over this. This is the same code we saw before for setting up MongoDB, and then it will be used throughout the code. This is setting up the database connection through a middleware call that's then available on all requests that come in. You'll see in the request handling, routing handling modules in the JavaScript there, for the Node Express usage, we can then get at the database by looking at rec.db. So that is taking this variable here and making it available throughout the code in the response routes. This code here is how we actually give out the React application that was built. So notice that we go to the build directory and we're using the path.join, and we're getting from the build directory index.html. If you remember, that is the built index.html that was bundled and built and exposes the JavaScript file that then can render React and our code that we built in React. And then this gets at the rest of the static content that is built with that React application. So this would surface any, ancillary JavaScript on the side or images or anything like that that we built with our application. These are there just in case the application shuts down kind of abnormally, and then we can exit. Now, if it does shut down, Elastic Beanstalk would restart it anyway. But we want to properly shut down. In other words, we don't want to leave any database connections hanging. So we call this db.client.close. That is a safe way to exit then. All right, here are the route handling capabilities. So this is one of those this is Express again. So we say use. If you ever see this route, then use this module. And inside there, we'll take a look at that next, how those modules work. So here's the different routes that we can take. There's also a heartbeat route. And then in this case, we just simply return back a status of 200 and the JSON that says how long the application's been up, message of OK, and the time. These two are for catching errors that happen. So as we mentioned in the Express discussion in video 2, you can raise errors anytime during the middleware routing, and this is where it goes. Finally, we set the port that we want to run on, and then we do the app.listen on the port. So our backend node is up and running and now can service requests that are coming in. Let's look at the files then under the routes folder. And we can see that they all basically look and work the same. They're set up to use this router capability from Express. So what we have done here is included by a require statement Express. And if you say .router, it creates this router object. And then off of that, you can get at routing through the different verbs. So we've got a router.post. and we got a router.delete, and we can do router.get. Then you give it the path that you want to get at. Now back in the server file, you can see that the main route that we're getting at from the path is, well, we go to our domain.com, right? And off of that, there's a path, API/users. Now inside the users, off of that /API/users, we can further specify the path. So this one is just right there at that same path, API users. This one, however, adds a /ID, and here's a get. So if we want to get a particular user, we have to do /ID. If we want to create a user, right, there's no ID, so we do a post right to API/users. So that's how that works. So each of the files uses this router object, and then we use the different verbs with the paths that we want to get at. So the function then that runs, well, we have to decide what's coming in on that. What are the headers, or what's the body? And so we can look at the request.body. Remember I said it's coming in as JSON. We have the ability to turn that into an object. So we're going to validate that that body, the JSON that's coming in, is actually complying to a schema that we have. Now, this is a great thing to do because you can validate all kinds of things about that schema. And we use Joy from NPM, a package, a module that gives you that ability. So we can say that body is an object, and it consists of display name, email, and password. So this is a case where we're going to create a user in the collection in MongoDB for NewsWatcher. You can say required, or you can say optional. So these are all required. That means if they were to pass in an object in the JSON that contained an additional key and value, it wouldn't be accepted. It would be rejected. So we call validate async, and we can say, yep, it has to have so many characters and all that for the required passwords. If it fails, then we actually hit the code down here, and we can return an error with a message for what that error was. Now, if it passes, we're going to try and find if that account was already existing in the database. It may be, right? They're trying to create, per an email, another account, and we don't let that happen. So we do a find one, and if there is a document returned, then we can say the email account already was registered. That gets returned as a 403, and here's the case where we do the next error, and so that's handled in the error handling, and then that message eventually reaches back to the React application and gets shown. And in the UI, you would actually see email account already registered. Well, let's say it didn't exist, so we want to create this transfer object, and that will contain, the display name, email, and it's going to contain the password hash. So the first thing we're going to do is create that password hash. So we use the bcrypt capability again. This is asynchronous, so we get that back. And then we can finally insert into the MongoDB the user document. Now, one of the things that's going on is that whenever the user gets created, or whenever they update the profile, we want to refresh what stories exist in their document, because the stories for a given set of filters for newses actually exists in the user document, right? This is denormalized instead of like a relational database that is normalized that would split these things out perhaps. All right, so how does that happen? So up above, we can require this lambda, and we can actually call it, if it's not production, right, we want to call it in our test environment. So that's pretty handy, right? I don't have to actually call the real lambda up in AWS. I can call the handler directly. This is great. So I can test it locally without having to deploy that lambda code up and potentially break something as I'm changing the lambda. If it's a production environment, we want to actually fire the lambda. So this is the case where we get the actual lambda from the SDK of AWS. So this is where we require the AWS SDK / client lambda, and then we can use the invoke command on it. This is a standard pattern for using anything in AWS. It would be similar if you were doing something with SQS or other resources in AWS. So we set up the params for our invoke command, and then we send the command and we find out if it worked or not. One of the things we're doing here is the event type, you can have it call synchronously or asynchronously. In our case, we're passing an event, which means invoke it asynchronously. The return will happen later, but we don't want to necessarily block ourselves here and wait for the response. We'll just fire it, and it works or it doesn't. All right, so we won't go through the details of the rest of this. It's pretty similar, right? If we want to do a get of an individual user, we use this syntax right here, as mentioned before, and then we can get the ID off of the param. So write rec /param /ID. So we could do /users and then 79534, whatever the ID of that user is, and we can get that. Now we do a test here to make sure that this is actually a valid user and actually from a token. And this brings up another interesting point. If you look at the code right here, it just goes directly to the function when this route comes in. However, here it has this added call right here, auth helper check auth. That is because in order to do a get of a user, we have to have a valid token. So we will have had to have signed in, got a token, and then when the call comes in, this is a capability to reroute or route before we get to our function. So if the authorization fails, we'll actually never get to this function because it will throw the error, and then the error handling middleware will come into play. So we'll get a chance to look at that coming up. So here's the get, all right? We get the user ID, and we can then return the document. There's also a put if you want to change something like the profile for the user. There was a delete we saw before. And if we go back to the server, we can see that anytime it's /sessions, we go to this file. This is what handles creating the token when somebody wants to log in. So when somebody created an account, it created a hash of their password that's in the database, and we're going to use that here. Inside this file then is a post or a delete, right, if somebody logs out. So this is basically the login capability. Now we have the same type of validation at the top here with Joy. We're validating that the password meets the restrictions. The email also abides by the restrictions. So we validate that. If that's true, then we look up the document by the email address. If the user wasn't found, no document, then we return an error. If it was found, then we've got the document here in this user local variable, and we can basically do a bcrypt compare. So this is the passed in password they're trying to log in with. This is the password hash, and it will compare, and if it matches, then we're good. If it doesn't, we can return a wrong password. If it does match, this is where we create the JWT token, and we can encode different things inside of that, like the session IP address or the headers, the display name, user ID. Don't put the password in here. That wouldn't be right. So you don't keep something like that. Then we return a 201, and then the JSON is basically this object, the display name, user ID, and then the token, and a message that says authorized. So the auth helper file is pretty short. So we mentioned that this is the middleware that gets called to check the authorization. So when you log in, you get a token, and then on the rest of the calls, in the header, you create this, or you place in that header this x-auth that has the token. And what we can do is then decode that with our secret that is in our environment variables, and we can look to see if it's decoded properly. If it is, then we can say, okay, we're authorized. If it's not, then we can say that's not a valid token. The user is not logged in, and we can return an error. So first off, if the auth header didn't exist, that would be an error. And then if it doesn't actually work out to decode it properly, then that would be an error. This is the module that we created, and we're exporting the router from this like we do on the other ones. It doesn't require authentication, so there's no token check here. Anybody can get the headline news just by going to the Newswatcher site. However, to log in, then you get your filters and your personalized news per your filters. So here is a call then that comes in, and we basically look to see if it was cached. So we cache on the server side the news stories. This allows us to not have to go to the database all the time. So we cache them for a certain amount of time. And there's actually a flag that regulates whether or not this is done. If the cache document's there, or if the time is expired, then we go to the database to get that. So we have one single document that holds all the global stories, and that's refreshed in the Lambda on a timer. So we go to the New York Times site, and we get the news stories. And then we're going to populate that document every so often. And here's where we're getting that then to return to the API call for this get. And that's where we get the document and return the home news stories. This is the Atlas console UI that allows us to look at any documents in a collection. So we're now looking at the Newswatcher collection of documents, and the one document that we have, you can see the ID is master stories do not delete. I created that myself. It's easy to look at and remind yourself, don't ever delete that. So on the timer in the Lambda, every once in a while, it will go and fetch the complete list of news stories. And so that goes here, it gets populated. And then the home news stories gets populated here. There's not as many, right? We limit that to, say, 30. If you remember from the demonstration in the React video, we showed the shared news. That's an area where you can take from your personal news feed and you can share it to the shared news. So what we have here is the ability to share a news story as a document. So these are separate individual documents that are of type shared story type. So we have to do the schema validation again right at the top. Then we do a count to make sure that we're not over so many stories, right? We have to limit that to how many stories we want. So that's an environment variable, maxed shared stories. So we may reach the limit. And then we want to make sure that the document wasn't already shared. So here we just looked in general for all the shared stories, and here we're looking for this particular shared story. Otherwise, we create our object here and we insert it into the collection. Here is a router.get. This is where we want to get all the shared stories. So we find the type of shared story type. And this is a call that if there's more than one returned, then it's going to create an object array of that. So this is going to have a JavaScript array that then we can return as docs. We can delete a story from the shared folder. So this is that ability. We can add a comment. So here's the story ID. And then passed in the body is going to be the comment that we want to add. So that's sharing the news. The last file to look at that contains JavaScript code for our Node service backend is going to be in this folder. So that's the Lambda folder. And we can see that it has a package.json, right? It's kind of standalone. It doesn't have very much in it. We've got the MongoDB because we need to converse and interact with the Mongo database. It's got bcrypt and async. So the file then for this is going to consist of a handler at the very bottom. Now I mentioned that it fulfills several different purposes. We could have split this code out and had several different lambdas. So really we're using it for three things. We're deleting stale shared news stories. So when the stories in the shared location get stale after a couple days, we delete them. The next purpose is for refreshing for an individual user. If they've changed their filter, we want to call in here and update to match the news stories that are for their filter change. And then this one is on a timer. This refreshes all of the New York Times stories in that main document, master document that we saw. Otherwise, it's unknown and we return an error. So let's look at each one of these individually. Here's for refreshing the New York Times stories. So we use the async because we want to run a series of calls back to fetch the news from the New York Times categories. So at the top, if you look at the API for the New York Times, you get to pass in a category that you want. So there's home news, world news, business, technology. There's lots more than that. I didn't want to get all the news from every category, like art or whatever, or finances. So I just got these as the categories. All right, so that's what we're doing here. This allows us time series to loop for the length of that, and then we can access that array here with the n, which is n is passed into the function each time it iterates through that length. And we call to the New York Times API. So you can see that the call is pretty simple, right? API nytimes.com. The path is top stories v2, the category, and other things like that. We have to pass in our API key. And so we're getting that from the environment. Now that gets returned. Once we get that, then I'm not going to go through this code. You can look at it on GitHub. We basically get the document that we want to refresh, and we put all the news stories in there, and there's a little bit of code that splits that out. Another thing we do is we set the home news stories as well. So there's, if you remember, there's two sections, all the complete stories and those that just belong on the home news. The next function we can look at is just refreshing stories for a user. It's kind of similar. So what we do here is we get that master global stories and we look at the filters, and so we can loop through, and for our filters then we can set up what the matches are, and so that then will populate on the user document those stories just for that user that are filtered. So one of the sub functions that it's calling is this refresh stories. This is where it's actually doing the matching of the stories. So each of the stories actually has a title and a content snippet. So we get the keyword and we try and match against whether or not those are included in either the title or the content snippet. And then finally we have the deletion of stale news stories. And that's simply a matter of getting the shared stories. So again, here's where we call that to array. We get all the types of shared story type, and we get that into an array. And then we can loop through that and basically do a timestamp check. So each of those documents has a timestamp on it, and we want to see if a certain amount of time has passed. And if it has, then we age it out and we call find one and delete on that document. I've opened up the AWS console, and I'm looking at the area for the resources for Lambdas. Here's where you'll find a list of your Lambdas. We just have one for NewsWatcher, and if we click on that, we can look at it. We actually can see all the code for it right here. So if we configure a test run, we can run it just from here, from the UI. We can configure it just for deleting the shared stale stories. We can run it, and execution, we can see we got a success. So the other thing we can look at here is the configuration. You can upload the code, right? You can test it. You can monitor it. So we could look at the CloudWatch events and see what was being reported there. So we can look at a log stream. Go back a bit here. And you can see some of the output messages from our console log. Go back here to the configuration. You can see we have the timeout set for 15 minutes, but in our code we actually will quit it earlier than that. It won't run for 15 minutes. Set the memory at 1024 so it runs fast enough. I experimented, right? If you set it down to as low as 128, that slider there basically allows it to run more efficiently. So again, it's a trade-off, right? If you run it at a low number for memory, then it takes longer to run, but it's cheaper to run it at that low memory. But the balance is to get it up where it's more expensive to run, but it runs shorter, so it's about the same. Also, there's a tipping point where as you run this, you get more and more CPUs if you're able to take advantage of the back-end pooling of threading in what's going on in your Lambda node code. All right, so other things, concurrency, we basically have it set up to use the unreserved currency. We don't need to reserve any for that. Now, calling this then from EventBridge, we have different rules. So here's the rules. Then here's one for deleting stale shared stories. And if we edit that, we can see the schedule. We can see it runs every 24 hours. The other thing you can see is the call. And as we mentioned, right, you have to pass in the JSON, the type of call you want to do for our particular code that looks in the handler. And this one says delete stale shared stories. That's that. Okay, so that's a good look at Lambdas. We could also look at Elastic Beanstalk. It's kind of a similar thing, right? You got configuration, you can set up environment variables and set up the scaling for that. So that wraps up the 3 videos that we set out to create. The first 2 being the introduction and overview of the server-side Node application with its JavaScript. And then this final one, we basically did a code review and walkthrough of the code for the Newswatcher application, talked about the security and hosting. And with that, we'll wrap it up. And don't forget to check out the book, which has a lot more details, as well as go to the other video series for the React and the MongoDB if you're interested in that information.